Good day, everyone. Welcome once again to our Math 051 class, Engineering Calculus 1. So this is part 6 of our review of functions. So today we are going to focus our discussion on conditional function. A conditional function is a function of the form h of x equal to f of x if we have condition 1, f2 sub x if our condition 2, and so on and so forth until we have f sub n sub x if condition n. So this is the form of our conditional function, where f1 sub x or f1 sub x and f2 sub x and so on and so forth until fn sub x are any of the previous types of functions. So it depends on what functions. So we have discussed the previous type of functions, so it can be any of them. And note that the conditions are mutually exclusive or disjoint. That is, condition 1 intersect with condition 2 and so on and so forth, intersect with condition n equal to empty set. Okay, so disjoint, exclusive or disjoint. That is a set of condition 1 that intersect with condition 2 and so on and so forth, intersect with condition n equal to empty set. For example, sketch the graph of the function. So we're given this function f of x equal to 1 plus x. So condition 1 is for x less than or equal to 3, and for condition 2 it should be 2 for x greater than 3. Okay, so similar things to do. We need to tabulate our data. So assume value for x, then assume solve for f of x. So here let us look at this first condition. So the first condition here is that x less than or equal to 3. So let's refer our interval in our number line system. So this is our number line system. We have the negative infinity here. On the right side, we have the positive infinity. So assuming this is our 0 here. Okay, so we have x. Our x is less than or equal to 3. Okay, so let's look at where is our 3. So this is 1, 2, 3. Okay, so all values that is less than or equal to 3. So it means, so this is our boundary. It means that all the values that is x less than 3. So where are these values? That is going to the left. All the values going to the left. And for second condition, x greater than 3. So it means all the values that's going to the right. So these are the values that's greater than 3. Okay, so let's draw our horizontal and vertical lines. So this is our x-axis, and this is our y-axis. Where y-axis is equal to f of x. So you can tabulate, or you just look at the expression, then follow the interval for each condition. So for example, for x less than or equal to 3, meaning all the values that is from 3 going to the left. In other words, we have the domain is, or the interval is negative infinity, then 3. So 3 is included. So we have to use this symbol. Okay. So where is it? So for example, let us label this first. So our negative 1, our negative 2, negative 3, negative 4, negative 5, and so on and so forth. Here we have 1, 2, 3, 4, 5, and so on and so forth. Let's have this part as 1, and we have here 2 and 3, 4. Okay, so considering this interval from this positive 3 going to the left, it means from here. Okay, so I just mark it here to give us the idea of, so it means with this interval, so what will be our graph for this part? Okay, so for this interval, assuming x equal to 3, so when x equal to 3, so our f of x is 1 plus 3, right? Okay, so to make it easier, so it's better to tabulate. So you have here x, then you have f of x, which is equal to 1 plus x. Okay, 1 plus x. And the other f of x equal to 2. Okay, so we'll do this table. So we add another column here. So stand for C means condition. So this is our condition 1. Okay, and this is our condition 2. Alright. So now when, so for example, when x is equal to say 3, when x equal to 3, then this belongs to condition 1. Okay, condition 1, x can be less than or equal to 3. So when x equal to 3, so that belongs to this condition. So your f of x, our f of x is 1 plus x. So ibig sabihin, so we have 1 plus x, our x is 3. So that would be 1 plus 3 is equal to 4. So this is equal to 4. Now if x is equal to, okay, I think we start with, okay, I'll complete the table first. Okay, let me do it again. I'll start with those values that are okay, let's start with the value, say any value to the left of 3. Like for example, if we have the value, say 0, when this is 0, so that belongs to this condition, condition 1. So 1 plus 0, so you have f of x is equal to 1. When x is equal to say 1, so 1 plus 1 is 2. When x equal to 2, x equal to 2, so 1 plus 2, so f of x is 3. Then when x equal to 3, x equal to 3, so 1 plus 3 is 4. Okay. Now when x equal to 4, so when x equal to 4, so this is no longer belong to the condition 1. So this belongs to condition 2 already. So we will fill up C2. Okay, so our f of x is equal to 2. So when x equal to 4, we have 2. When x is equal to say 5, so again that is greater than 3, so that is also 2, and so on and so forth. So if you continue that one, when x equal to 6, so that is always 2, so meaning constant. So if you graph that one, if we graph this, we have when x equal to 0, f of x is 1, x equal to 0. I'll change this color first. Okay, so when x equal to 0, so using this point here, so that belongs to condition 1, x equal to 0, f of x is equal to 1. So at this point here. Okay, so this point here. Now when x equal to 1, so we have f of x is 2. So 1, so f of x is 2, so it's somewhere here. Then x equal to 2, f of x is 3. Okay, so f of x is 3. Then when x equal to 3, x is equal to 4. Sorry, when x equal to 3, f of x is equal to 4. So 3, and then we have 4 is somewhere here. Now when x equal to 4, so now we are in the condition number 2. So x is greater than 3, so 4 is greater than 3, so therefore we have f of x is equal to 2, so it means it's here. When x equal to 5, so that is still 2. So at this point, so if you continue this one, when x equal to say 6, so 6, so that is still 2, because 6 is greater than 3. When x equal to 7, so we still have f of x equal to 2, and so on and so forth. Okay, so now if you are going to connect, the points, so we have here, by the way, if you, for example, if you assume value here negative, say negative 1, okay, so assume tayo ito ng value na negative 1. So when x equal to minus 1, so minus 1, so this is minus 1, so 1 plus minus 1, so this is 0, f of x is 0, so we have 0. So when x equal to minus 1, f of x is 0, so somewhere here at this point. Okay, so connecting the points, so we'll have this straight line. Okay, and we also have this one. This is a constant, condition number 2, constant, for x greater than 3, then you have a constant 2. Alright, so that's how to graph the function, conditional function. Okay, so this is the original graph. Okay, so this is what we have done. Okay, so if you look at this, this is the graph. Okay, so hope you understand with this one. You can start. I started 0 here, or negative 1, but you can start with negative 5 as long as this is on the left of 3. I'm going this using this interval, and for this one, so this is the meaning this interval class the same as that is for condition 1. This is for C1. So condition 1, which is x less than or equal to 3. So that's the same with this. Then x greater than 3, so the x greater than 3, condition 2, so x greater than 3. So this is the same as, so greater than 3 meaning excluding the number 3. Okay, so you have here 3. So this is the other interval, 3 to positive infinity. So we use the symbol parenthesis for this one because 3 is excluded. So we have x greater than 3, meaning 3 is not included. So that's why here in our graph, so 3 is not included. Or you can, another way of presenting it is okay, in color. So this one x, so meaning this is a hollow. This is a hollow here. Okay, so it means that three is not included. Okay, so that's our graph. Right, so any question? Okay, so let's proceed to another example. So sketch the graph of each function. So we're given here y is a function of x, or y is g sub x. So we have three conditions here. Okay, condition 1, for x greater than or equal to 2. So we have f of x or g sub x equal to minus 2x plus 8. And for condition 2, for the values that is between minus 2 and positive 2, excluding 2, so you have the second condition x squared plus 1. And for condition 3, 2x plus 8, so that is on the interval x less than minus 2. So what are values less than minus 2? We have on the left of minus 2. Okay, so for our reference, let us again draw the number line system. Okay, so in our number line system, okay, let's make it longer. Right, this is our positive infinity. And here is our negative infinity. So assuming this is our 0 here, so the values we have is to consider this as our 1, this is our 2, and we have here minus 1, minus 2. So this is not a standard class that I put only or label it until up to negative 2 and positive 2. So you can do more, no? It's up to you. Alright, so we have here condition number 1, x greater than or equal to 2. So where is it? Okay, so let's draw this boundary. So this is the area or the interval. So this is the interval for x greater than or equal to 2. Right? So in other words, you can also write it in this notation. For this interval, you have 2, 2, positive infinity. Okay, so going to the right. Then we have interval here, -2, meaning x is greater than or equal to -2, but x is less than 2. So in other words, we have this other interval, so meaning it's between this -2 and +2. But if you look at this, you can write this as -2 is included, so you use this symbol, so -2, okay, and +2, but +2 is excluded, so you have to use this symbol. Okay, so there's no equal sign here, so 2 is excluded. So to represent that later on, that indicates a hollow. And the other one is x less than -2. So in other words, all the values that's going to the left. Okay, so all values going to the left. So these are values that for the interval x less than -2. So you have on the left, you have the negative infinity, then -2. So you have -2. So -2 also is excluded. Okay, so use the parenthesis symbol. Okay, next thing to do is let's draw our x and y coordinates first. Okay, so let's draw this. So assuming this is our x-axis, this is our y-axis, or y is a function of x, or in this case we're given y is g sub x. Equals g sub x. Okay, so this is our so we label this one as this is our 1, this is our 2. You can put some more number. Oh, sorry, this is 3, this is 4, this is 5, and so on and so forth. On the other side, you can have also -1, -2, -3, okay, so we extend this line now, -4, -5, okay, and then for the y-axis we have 1, 2, 3, 4, and so on and so forth. Okay, so we'll do that again later. Okay, so next we have to do the table. So we have x here, and we have g sub x so g sub x, this is for our condition 1. Okay, so we put it c1 here for condition 1. Then we have another g sub x that is for condition 2. Then another g sub x for condition 3. Okay, so condition 3. Sorry, this is condition 3. Okay, so let's tabulate. So these are our conditions. C, condition 1, condition 2, condition 3. And I will not write anymore this formula here. Or we can write if you want. So we have condition 1 is 2 negative 2x plus 8 and condition 2 is x squared plus 1 and condition 3 is 2x, I said 2x plus 8. So for AC reference it's better to write it. Okay, so if we assume values for x, say let's look at the intervals here. We have negative infinity, negative 2. So we can start perhaps say if we assume say negative 5 for x equal to minus 5. Okay, so that belongs to this interval, this condition. What condition is this? This is condition 3. Okay, so we fill up condition 3. So this is condition 3 that x less than minus 2. So x less than minus 2. So from negative 2 going to the left. So you can assume minus 5. So we'll fill up this. So the formula is 2x plus 8. So when you have x equal to minus 5, so 2 times minus 5, this would be 2 times minus 5 is minus 10. Minus 10 plus 8 is negative 2. Right? Now let's consider, say, minus 4. So when x is minus 4, that is still belong to this condition, condition 3. So 2 times minus 4 is minus 8 plus 8. So this would be 0. Okay. Now if we consider minus 3. So when x equal to minus 3, so still condition 3. So 2 times minus 3, minus 6 plus 8, so positive 2. Then for x is equal to minus 2, x is minus 2. So what is, so this is 2 minus 2, 2 times negative 2 minus 4 plus 8, so positive 4. Alright, so we have finished with this interval. Okay, so let us try to plot this first, this condition 3. So x minus 5, when x equal to minus 5, we have g sub x, our vertical component, that is negative 2. Okay, so because 2 times minus 5 minus 10 plus 8 negative 2. So it means, okay, so this is our, so assuming this is our negative 1, assuming this is our negative 2, okay, so when x equal to minus 5, okay, I'll change this color first. So when x equal to minus 5, our g sub x is negative 2, so it's somewhere here. Okay, just estimate it's somewhere this point. Now when x equal to minus 4, so 0, when x equal to minus 4, this is 0, g sub x is 0. Okay, now when x equal to minus 3, positive 2, when x equal to minus 3, positive 2, so it's somewhere here. So 3, okay, somewhere here. When x equal to minus 2, positive 4, so positive 4. Okay, so minus 2, positive 4, so it's somewhere here. Okay, so somewhere here. Now since minus 2 is not included, so instead of point we have to make it as a hollow. Okay, so let's make it a hollow, because minus 2 is, look at the condition, so minus 2, so excluding minus 2, so we put this as, we put a hollow here, so this is a circle. Okay, this is a hollow. Next, so next interval, so we'll use this interval here, positive 2, no, so this interval, sorry, negative 2 and 2. Okay, so again we'll use negative 2. Let me erase this one. Just use the same color. Just read. Okay, so when using the same value, -2, okay, for this condition number 2. So -2, we also have x squared plus 1. So if in the condition 2, x squared plus when x equal to -2, so square that 1 plus 1, so we have for condition 2 this is 5. Okay, so -2 squared 4 plus 1 equal to 5. Next, say -1. When this is -1, okay, so this still belongs to condition 2. So -1 squared 1 plus 1, that is 2. Okay, and then we have 0. So 0 squared, 0 plus 1, so this is 1. Then we have here 1. Okay, so 1 squared is 1, and plus 1, so that is 2. Then we have positive 2. Okay, so positive 2, so we have positive 2 squared plus 1, so this is also 5. Okay, so we've done with this interval. Now let's plot the points. Okay, so again starting with -2, when x is -2, f of x is 5. Okay, so or g sub x is 5. Let me change this color first to red, and I'll extend this one. So we have here 5. Just so this color blue. Alright, so when x equal to -2, we have g sub x, the condition 2, so g sub x is 5 minus 2, so this is, since -2 is included, so this is a point. This is a point. This is not a hollow. Okay, this is shaded one. Okay, and then when x equal to -1, when x equal to -1, we have, when x equal to -1, we have g sub x equal to 2. So g sub x equal to 2. Okay, so here. Okay, so this is a point also, a shaded point. Then when x equal to 0, when x equal to 0, condition 2, 1. So kung 0, ito sa 1. Okay. Now when x equal to 1, okay, 1, so g sub x is 2. When x equal to 1, g sub x is 2. Alright. Then when x equal to 2, g sub x is 5. But take note, 2 is not included, right? Because it's not equal to 2 but less than 2. So when x equal to 2, then g sub x is 5, but this time this is a hollow. Okay, so this is a hollow. So this is a hollow. Okay, next we'll go to this condition number 1. So x equal to 2, so 2 is included. So condition 1, if x equal to 2, here condition 1, x equal to 2, so 2 negative 2 times 2. Okay, so negative 2 times 2 is negative 4 plus 8. So this is positive 4. Okay, so for condition 2, when x equal to 2, positive 4. Now when x equal to 3, okay, let me change this to other color. Go back to red. So when x equal to 3, so again we are now in this interval class, for this interval. So when x equal to 3, so 2 times negative 2 times 3 is negative 6, plus 8 is 2. Plus 8 is 2. Then when this is 4, x equal to 4, so 2 times negative 2 times 4 is negative 8 plus 8, so this will be 0. When x equal to 5, okay, so when x equal to 5, so negative 2 times 5, that is negative 10 plus 8, so negative 2. This is negative 2. Okay, so let's plot condition 1. So I'll change this to another color. Go back to blue. Okay, so let's plot beginning from this point. So condition 1, when x equal to 2, so the condition here, condition 1, x is included in the domain. So x is 2, g sub x is 4. x2, g sub x is 4. So this is shaded. Okay, this is not hollow, this is shaded. And when x is 3, g sub x is 2. When x is 3, g sub x is 2. Okay, so this one. So it means at this point. Then when x is 4, 0. So when x is 4, so this is 0. And when x is 5, negative 2. When x is 5, negative 2. So here. Okay. So now connecting the points. Okay, change to another color. Alright, so connecting these points. So for interval, this interval here, so connect the points. So we have this, okay. Then we have another one, this one here. Connect this point, and this one. Okay, so since you can use more points or more values for x, so you can put an arrow here, and so do with this one. So you put an arrow, so to indicate that you can still assume more values. Okay, so this is it, and this is the ready-made solution to this problem. So you've seen here, right? This is okay. So this is shaded. So if you look at this, this is shaded, and this is hollow, right? So this is hollow. This is solid. Okay. So I hope you understand. And we have two more exercises here, but I will not solve it. I want you to practice this one. Okay, so try to solve this by yourselves. And if you understand the first two examples, I'm sure it's very easy for you to do it. Okay, so I will end our discussion at this point, and let's see again in the next part of our review of functions. Thank you very much. Have a good day to all of you. Bye.